just show up.
We'll be there. Yeah. But anyway, welcome and thank you so much.
Good. So I would want to say thank you to all of you for showing up for this. Something I value so much about groups like this and what we do in construction is learning from each other. Whether it's CBUSA or IBS or the HBA, it's just being able to pick the brains of other experts or experts in the industry and learn from that. And just an encouragement and exhortation for each of us to continue to educate those around us and pass along the passion and just ingenuity in what we're doing to elevate the industry. We know it's a need, we believe it, and by us speaking that and teaching those around us, it's going to continue to help grow. And I think this group and the kind of the groundswell that we're having is testament to it. So thanks for being here. We'll keep this going. So we'd like to say thank you for our sponsor. So Jill, the floor is yours.
You. I appreciate it. No, thanks to Chris Knight and Chris LG for inviting me when I heard you all are the who's who of the smarties over here that are doing all the building science. I really wanted to be a part of it. So I appreciate your time. We are a waterproofing manufacturer, yes, out of Texas, but we have taken it to a whole nother level. So what we've done, it was our passion to take not just the waterproofing products and make them water and airtight, but we wanted to make them also termite resistant, termite proof. It's never been done before, but why aren't we doing that? Especially now we're building so much more with ICF and rigid foam on the exterior and below grade, we have to protect it. And imidacloprid injected ICF and the styrofoam is not going to do it because imidacloprid is water soluble. So we've come up with the sealants. We had Texas A&M help us develop a sealant, first and foremost, that the termites could not bite or chew and get their mandible around, because it's the soldiers out there that are going to be biting and chewing into the structure. And even though you might be building steel and concrete, and I get it all the time, they're like, Jill, we don't need it, don't worry about it. We're going to do soil termiticide as a pre-treatment, and then we're going to build with steel and concrete. And guess what? They're still getting into schools and structures and everything else because they'll find a silicone joint, they'll find an expansion joint and get in there. So this is the first thing they helped us to develop. We extrude it and put it into all of our peel and sticks. The guys that install it don't look at it any differently, but it is slightly different with the termite sealant in there. They cannot bite or chew through. We've got under slab, we've got flashings, we've got a seal membrane, which has never been done before. We also put this in quarts and gallons, and you can put it around as soon as your slab is poured. Think about all your penetrations through that slab. That's a highway for the termites, for cockroaches, for ants, for spiders. Pull that plastic sleeve off, pull the insulation off, and seal that pipe around there. And then go ahead and frame. Then you're set for the life of the structure because this stays elastomeric, it doesn't dry out, and nothing can get through, and it's waterproof. So things like that we've thought of. We've got an entire system for your building envelope. This is commercial and residential. It's commercial grade, but we use a lot of it, obviously, for high-end homes, for passive homes. So come see me. Be happy to tell you all about our products. We've got a lot of swag. Please take that. I've got crumble cookie coming in individual boxes. They're just going to be here a little late, so take one of those on the way out, too. Thanks, guys.
All right, Jill, thanks for inviting you back. All right, Chris?
Yeah, Jill's going to bring crumble every time. You can
That's
sponsor
right.
everyone. Yeah. Well, thank y'all for being here. This is going to be a fun discussion. My name is Chris Knight with New South Homes. We do custom homes and renos. I'm mostly just going to try to get out of the way tonight and let these three guys talk to you all about Passive House. So let me first introduce who we've got here. I'm sure most of you know who they are, but first we've got Chris Laumer-Giddens from LG Squared. He is the architect / Passive House guru for the evening. Carl Seville, SK Collaborative. He's going to be our maybe anti-ish.
He's not the
curmudgeon we love. Yeah. And then Allison Bailes from Energy Vanguard, chief troublemaker.
He's Switzerland.
Former South Facer.
Former South Facer. Yeah. So guys, I'm sure.
Are you Switzerland tonight? Perhaps.
Allison, you're Switzerland tonight.
Is this sales pitch or battle royale? What are we going for?
Let's make it all.
All right, let's go.
I think Chris is selling and Carl's trying to say no.
All right.
So let's dive into it. I want to start, I know Chris has a couple of slides he wants to show, but so Chris, start off by telling us kind of the basics. What is Passive House? What all does it encompass in the scope of our project? Maybe you can give us a couple of examples of normal high performance versus Passive House, stuff like that.
Thank you all for coming, and the interest is amazing. Please take a bread knife when you walk out of here, because Rockwell sent me several cases of them, and in case you need them to cut the bread. Also, feel free throughout this whole thing to call BS on us, and I don't mean building science. We want to be challenged. That's the whole point. That's how we got to where we are. We've been challenged, and we challenge others. So, thanks for coming. And so, cord is too short, so. Power on, please.
Power to turn on? We might be high performance, but we're not high tech. That's right.
More juice, Scotty.
Yeah, it's going. Okay.
So where did you say you were from?
Yes.
I was just trying to, anyway.
Yeah.
So what the F is FIAS, right? That's why, like a lot of people, it is a certification. It's volunteer, just like Earthcraft, just like Energy Star. It is for builders to, essentially, like all the programs, it's to get the builders to follow, and it's more geared towards designers as well. So but it is a program certification to make sure we're building to a standard, and it is the strictest of them all. And it's been brought over from Germany, which is even more strict. When it first came, it was just one standard for the entire country, and they've now broken it out by climate. And now that's what we're going to talk about tonight, is what does it look like in the Southeast? Because, Southeast, it's hot. Why do we need insulation? What is all that, do we need all that, right? So before I get into that, just a real quick plug on Carl Seville and Allison and any other mentor I have in this room. Get yourself a mentor as in this industry, and whether it's high performance, architecture, whatever it is. I just wanted to say thanks to these guys, and Brian Jones is another one. You all know who have helped me in the past, but I just wanted to say thanks to them. Allison taught me how to juggle and ride the ducked pony. And Carl has been my bullshit mentor and keeping me from overthinking. I always call him. The first thing I say is, I need to know if I'm overthinking this, and he's always
yes.
Yeah, it's always the case, right? So what does it mean? Okay, this is just my little disclaimer. So this is basically not as much about me being offended by you using the designs. It's making sure you cover your ass, okay? Because you take these designs and apply it to any job. We get so many projects or clients coming to us and saying, I found this on in Joe Stiebrick's book. We're going to use it on our house. You're in Florida. That's for Maine. Like let's not overdo it. It's going to cause problems. So just make sure that if you see anything here, it's fine. Get permission. Talk to me. We'll modify it for your project or whatever. Just make sure it works for your project. But all right, back to the question here. So what does it look like in the Southeast? You got to know your climate. That's why all these details just don't work everywhere. From one house to the next can be different. The details can work differently. Orientation, number of windows, number of people, all of that matters. So get to know your climate. That's the very beginning of it, is really understand what your moist, exposures and what the ground is doing to your building, and the trees around there. Are they going to die soon? Or could they burn? You got to be ready for anything, and so you got to understand your climate and conditions. You take the information of your house, and this is a tool that FIAS has, and you put in these numbers here, and they tell these are your targets for heating demand, cooling demand, heating load, and cooling load. Everybody know the difference between demand and load? Load is momentary. It's like, what is the heat loss right now or heat gain? This is the energy it takes to heat up your house or to cool your house. So that's what these are numbers that we have to meet these targets or do better. This is another target here, FIAS Core. This is what most people are doing. Zero is zero energy, but this is kilowatt hours per person per year. These are the numbers of the project I'm going to share moving forward. Just some basic building science things about not just passive house projects, passive building, high performance, just doing better, durable, you know, lasting forever, high performance. We all have heard about the perfect wall, getting your layers proper, in the right spot. I've added several layers, the beauty layer, the fire control layer, and the UV control layer. Hey, settle down. As an architect, of course, I appreciate that, but as Joe Stiebrick says, ugliness is not sustainable. So we gotta make sure our buildings are pretty, and we wanna take care of them as well. But fire is a big issue now, especially in California, but it's also an issue here. We do see fire, especially up north. But up the house we're building now is surrounded by trees. It's a 2-acre lot, and it was just super dense with trees. So you're usually pretty wet because of the rain we have here, so they don't burn very much, but we still have that concern. But then the next step is to connect them all. Your wall is your floor, is your roof, right? And then just connect them and be perfectly, do a perfect envelope with your perfect wall. Okay, so this is the project we're doing, and this is near Grant Park. And it's Craftsman. The owners particularly wanted Craftsman and to fit within the content. This is a very early rendering, very schematic, but just to give you an idea of, there was a lot of complexity here. You see a lot of rafter tails. Those are not penetrating the envelope, and I'll show you how we did that. But there are reasons for that. You want to have a perfect, like totally uninterrupted to get your air tightness down. I'll address air tightness, Mike.
Real quick on that, overall architecture doesn't impact
No,
certification.
correct. No.
You can do any style architecture.
Yep. Yeah, it's the metrics. Meet the metrics and you
Just
get
hit their performance.
Yeah, the performance, that's right. But they also recommend fewer corners because that makes your building more efficient. Inside corners. And a lot of that's based on poor construction because your corners is where you find the leaks and that's where you lose energy. But if you do it right, fill it up with corners. It does take more work and sometimes more insulation in that. But like penetrations, I don't care about penetrations. I know how to treat them, you know. So it's like, just do it right, and it's okay. So the slab is an 8-inch slab. It's a Raft slab. The whole thing is just 8 inches thick all the way across. We got 2 inches underneath. Now it sounds like a lot, but I've done the math, and it's actually the same amount of concrete because the slabs that we design, they're usually grade beams around the perimeter. It's not just a turn down because we want to have this insulation be continuous. So I need straight edges, not that sort of unknown angle, right? So this is a detail we've worked out with our engineer, and this is the kind of thing, I mean, don't just copy this unless you know your loads and let your engineer figure out these details. So we've got 2 inches on gravel, 8 inches of concrete, and then we did a little insulation up here to soften the surface for walking. 2x6 walls, 2x24 on center, filled with a wood fiber insulation or a loose fill dense packed insulation. I do not want to install the bad insulation. I don't know anybody that can do it better than I want it, so I don't have the time to do it myself. So I'm going to blow it in because I want to fill up that cavity. I've done most of my projects. We do everything to the outside. Just put all the insulation to the outside, simplify, let the trades love it. Let's not worry about cavity because it just can get, you know, it's cutting around the wires and all that. So, but now we're finding this balance works really well, and it's a good, it's cost effective as well. Do it.
Did you not do wood fiber on the outside because of termites?
It's also not available, but yes, that's a big part of it. They do have the borate in it, and it is shown to actually be a termite resistant product, but it's not been tested, and I've just, and rocks are just better, period.
Chris, on the previous one, you were showing slab, under slab installation. Do you have a detail on the edge?
Yes, I do.
Is that coming up?
Yep.
Thank you.
All right. So furring strips are on the outside of the stone wool. And those hold the insulation on, and then the siding is attached to the furring strips. The spacing of the furring strips and the fasteners matter. So you just have to know the weight of your cladding matters. So you have to know that determines the spacing.
So you mentioned cost effective compared to what?
Going all to the outside, because when you go, we did another passive house project that was a renovation. We basically stripped it to the studs. To keep everything to the outside, we had 8 inches of continuous on the walls, 10 inches on the roof, and we had to fill the cavities in the roof to make it work, and triple pane windows. So, but that was a super complicated building that had a messy foundation that we had to.
You can see that on Sawhorse's YouTube channel.
Yeah, yeah.
Okay,
Yeah.
cool.
The roof is 2x10s, stick framed. We did encapsulate, or we did bring the attic into the thermal enclosure to use for mechanical and storage. So we have 2x10 stick frame with 3.5 inches of continuous on the roof. Just as we move forward, none of this is, some of these decisions are because it's a good assembly, not because Passive House is making me do it, or because the numbers are telling me. I could go less than this and still meet Passive House. This is just, the budget was okay for this. This is a better assembly.
Is that a vented roof?
No,
That-
that's vented on the outside, but it's not it's an unvented, it's a semi-conditioned attic.
Can you go back for just one
Yeah.
second? So the orange is all insulation?
That's right. And then we have a fabric at the bottom holding it, that's our reinforced netting. And then 1x2s coming, giving extra support.
Have you ever had the issue, we have a leak in our roof, but it shows up over here, but the leak's over there because water's migrating through that,
Insulation?
well,
Well,
through the airspace, what I'm saying, the airspace, the 2x4
Here?
wood flooring strips, yeah.
no, that's a drainage, that's my rain screen cavity, drainage cavity right there. That's on top of this rigid insulation. If water gets to that, it'll run down, the 2x4s are at 20, or at 45 degrees, and they run to the edge, they run out. I also have a peel and stick on the sheeting here.
Okay, I see it where you wrote it now, okay.
Yeah, vapor open sheeting, peel and stick here. Yeah.
Why the 2x4 instead of 1x4?
Better ventilation. The hygrothermic's telling us that's gonna give us better drying potential for the assembly. And so we don't have to have a ridge, like a ridge, a vapor diffusion vent at the ridge, which allows the moisture. This assembly works all the way to the ridge and all the way to the wall without any vapor diffusion ports. But that's just better ventilation. 1x4 works, but this is better. Speaking of hygrothermics, we just run some tests on all our assemblies to make sure that they're gonna dry well throughout the year. This is our target, our threshold, and all of the assemblies are well below that, so our sheathing doesn't get wet. No part of the wall gets wet that we don't want to have wet. And if it does get wet in some other assemblies, it'll dry out. Yes,
Is that a model or is that testing?
that's a model.
Okay.
Yeah.
What is that? What's
Woofy, it's woofy.
Okay.
Yeah. This is the assembly at the edge.
Thank you.
Yeah. Just, I'm increasing this to 3.5 because of, this is one of the greatest, biggest heat loss happens at your exit. It's like a super highway for heat.
And what's the insulation product again? I'm sorry.
Here is it's all stone wool. This is it's stone wool, but rock wool.
Right.
Down here, we used a higher density because we have loads on it. Most of the time, you can use Comfort Board 80, which is a lesser dense. This is all Comfort Board 80, 3.5 at the edge to slow that down. Our thermal control layers, all our control layers turning the corner all the way up. All this goopy stuff in here is polywall, reinforced, all of our liquid applied membranes. We're gonna wrap the entire house. We're gonna use sheathing, plywood, and then just cover the whole house in blue liquid. The whole thing will be used. Our painters roll it on, and it's and I'll talk about that in a second.
Hey Chris, I'm sorry, the brick, where it steps off and it looks like there's like a 2-inch gap up above.
Yes.
There, what's going on right there? Does that step back?
Yeah, we have we have our drainage system here that leads to the weep holes.
But do the bricks step back, or is there a
No,
2-inch gap?
that's just 2 inch. Just to get our Yeah, and it's nice depth for architecture.
Did you do anything in that brick assembly to catch like mortar or anything like that?
This is a mortar net system here. Yeah, this product is by mortar net, and it goes runs around the whole thing.
Is the rock wool the form for the edge?
Yeah, yes, it is. So we're actually going to pour. This is the brick ledge, and it's going to contain our gravel. And then we'll have our insulation run, and this will actually be formed with just formwork, and then we'll come and apply that later. If this was right up against dirt, yes, we would use the insulation. Yeah. We've done that with turn down slabs.
What's that fill between the rock wool and the brick at the bottom?
This here?
Yeah.
So this is part of the mortar net detailing. They recommend filling that up with mortar so that it doesn't, because otherwise that can cave in. Like the weight of the mortar can cause it to break. So this supports the mortar net product. So I'll throw one to Matt for Risinger, but Monopoly framing, you all have heard of that? So continue this around from wall to roof. This is a heavy timber 4x8 rafter tail. It's aligned with the framing below, and we have three timber lock screws that attach that to our 2x10, and then we run insulation in between the rafters. But we frame everything, all the plywood's in, the liquid applied membrane is on over that. Just all the way up, continuous, uninterrupted.
And those tails stop like right there, right?
That's right, you go to, you just keep this ratio, whatever that overhang is here, you just make sure you get 1.5 back. And this has, the number of screws and the size of screw matters, and the structural engineer helps with that. Real quick, this is a complicated little sketch, but what we've done is to help with thermal bridging at the windows is we've run the stone wool insulation all the way around, and we've just used intermittent blocking to attach the window and also to attach window trim, interior trim. So this runs all the way around, and then we have an air barrier that runs in between here. This insulation serves as a backer rod for all the way around the perimeter, and then goes between the window and the frame. Okay, numbers. I mean, this is the heat. This is the target. Here's where we are with the. Can you all see that?
Oh no. You're down significantly. You're down significantly.
I don't know how to.
Do you like there's a.
I forgot my mouse at home. Anyway, so heating demand. That's the energy we use to heat the house. Cooling demand, same thing. These are our targets, and then this is the actual. That's where we're at with this. And then heating load. Do not use this ever. Do never use WUFI for your heating load calculations.
Why?
It's always smaller.
Than real life.
It's always smaller.
Huh. No, it's smaller than manual jig. It's smaller than real life.
And actually, you know what? I take that back.
All of the feedback.
Well, yeah. So this is total heating load for the house. I'll show you the number. This right here, I'm at. You'll see the numbers later. I got a comparison.
The targets are FIAS targets, right? That's what
FIAS
you're
targets
focused on.
based on your location and the size of basically the perimeters. Okay. Here are our targets for energy consumption, and there's a little surprise on this house, and it's not just they have some extras that they want in the house, and we're still meeting. Here's our EUI. You all know what EUI is, Energy Use Index. So that's just the amount of kilo-BTUs per square foot per year that is used in what other programs, I guess. Anyway, it's not called EUI here, but it's called specific site energy. Site energy is what's produced, is what's consumed on site, and then there's source energy, which is all the energy consumed on site and the energy it takes to get it to the site. Those are also targets that we have to maintain. So air tightness, here we go, Mike.
No, wait a minute.
That's possibly excessive.
So this is, okay, so this is CFM per square foot. This is not
That's very
ACH
low.
50, okay? But our ACH 50 number is 0.05.
Why are you doing this to yourself?
Hang on.
It's all bragging
One
rights, that's
second.
all it is.
Just hold on a second.
You can't open the door.
So Mike has accused me of being a bit OCD on air leakage, like chasing the numbers, right? Well, check this out. The roof was 3.5, it's 3.5 inches with 9.25 insulation in the cavities, right? 3.5 on the outside. If we reduce it to 2 inches, let's save some money, 2 inches, 7.25, and we go to the FIA standard of 0.05 CFM 50 or 0.72 ACH 50. We're bust. We're not passing. We're not meeting the passive house standard. If we go to an ACH 50 of 0.05, we've saved $12,000 on the material by reducing it from 3.5 to 2 or 9.25 to 7.25. Just on the roof. This is just the roof assembly that we're looking at here. So I've saved 12 grand on this project. Just by making the house extra tight. So I'm chasing these numbers, not the air sealing numbers, but I'm also chasing, we've had several houses in the southeast that we've built to this, and I'll show you a house next, a Smurf house, that we did 0.05 ACH 50, no dehumidifier in here in the southeast. It's never been needed. Another house in western North Carolina, it's all been plumbed for it, but it's never been needed. 2 other houses here in Georgia, we've done the same thing. Air tightness just tells us that most of our humidity, most of the moisture is coming through the cracks, not from the people and what we do inside. Now that can cause a lot of moisture as well. But South Face monitored one of those projects for 2 years. The data shows that we didn't need a dehumidifier for those 2 years. So we've done it. This is the house that we did up in Marietta, 0.05 ACH 50.
And that's rolled on.
That's all rolled on with by a paint, and he took it on, and he was so proud of it afterwards. He comes back to me now, and he says, I did another house, and we got down to 0.7 ACH 50 or whatever it was. This is another example of like building your rafter tails on the outside of your building envelope. This is like, these are outriggers built after, so that's before, that's after. And we actually blew in 0.09 ACH 50, right, David? Because I think you did the test. And the reason we changed it to 0.05 is because we made an assumption that all of the air leakage was happening right here, outside of the blower door frame. And we knew that, we know the air was coming out there because someone was inside doing an inhale and exhale test.
What's that?
As in breathing?
Californians know this one. We were smoking dope inside. No, sorry, I thought I'd get somebody. No, we had a fog machine running there, and so like we were just seeing this gushing fog coming out the blower door frame, and nothing else. There was one window, just a tiny little leak.
So Chris, I'm not quite sure I'm wrapping my head around. You're like an order of magnitude more tighter than your sort of half, right?
Right, 10 times, yeah.
Yeah, but that means you're going from, I don't know, 400 or 300 on the blower door down to 30? Is that?
Yeah.
And you're saying that effort is attainable and doable and worth it?
Yes.
It's hard to grasp that you're saving 250. You're saving 250 CFM, but obviously your numbers are looking good. I'm not trying to question that.
No, and this is where, when we get into costs, which we will, it's how much more did it cost to do it, and it's a matter of your values. And if you value a good envelope, it takes more thought, not necessarily more time. This enclosure here, we saved a little bit on the plywood, and then the polywall did increase the price, but our labor kind of, to get it perfect, these are paint rollers, and these guys have been doing caulk they're always running caulk into the corners. He actually licked his finger on the corner on the outside of the building. I said, slow down.
Um,
But he was having some, anyway.
By the way, get those low numbers
That picture is with a blower door, we weren't able to
Yeah,
use
you
the
couldn't
blower
use
door.
the blower door.
No. There's a window on the back side of the house, he ended up using a duct, he had to buy a duct.
Yeah, you have to buy a separate,
Right.
canvas for it.
Yeah, so, yeah, I mean, and I think with the comfort level and the moisture, having to control the moisture, it's sort of like, you know, the domino effect. It just affects so many things. It's not just the one air tightness.
Is there any data about how long a home stays that tight? I mean, after the wind blows on it and.
So I think Jill can really attest to, or talk about this, but this stuff is extremely pliable. It sticks to just basically every material that's out there, and especially when you're bridging materials like we did between the, you can see we bridged the framing to the slab. Any movement there, it goes with, obviously big movement, it's not gonna hold, right? But all that movement is, the membrane is going with it. You can't, you know, and so that's another reason of using the product, is it helps us apply it to every material and keep it strong. Okay, before I jump to the next project, the next thing we'll do is look at Carl's house. I want to show a quick section just as a comparison, so then we get into.
Actually, Kristen, can I, to go on Hank's point, how long will it stay airtight? To a certain extent, forgive me, let's go a little further. You become so OCD here, that how long is your project going to stay as is without weather? Like the Craftsman house,
Yep.
been around, you know, good lord.
Sure.
People that are living something close to Craftsman. They've been around for, what, about a century?
Yeah.
And then now we're starting to have to do repairs, this kind of thing.
Yeah.
You're spending so much time making this and making it phenomenal. When will you start making it so that you know your house is gonna last a century? And is there a way to get some insurance from that because your house is such high quality?
So well, a lot of ways to answer that. But the material, this material here, of course, it has a life if it's exposed to UV. It'll start to break down over time, but we close it up before it has a chance to start doing that. Once it's wrapped up, Jill, you can answer this one as well, but it only gets stronger with time. These EPDM, STP, thank you, the other acronym, STP-based products, they get stronger with time. Like zip system tape is done by 3M, and their tape just gets stronger with time. These adhesives, all of these products, they're just getting stronger, especially if they're not exposed to the UV. So the concern is renovations, and you don't have the same crew doing the renovation that did the construction. That can destroy it. My tiny house in Florida, that happened to it. They just added a wing and said, no stone wool, we're doing spray foam. I don't want anything to do with it. You know, so don't call me. But they just destroyed the whole building envelope that we had built. So yes, that is a concern because we're using techniques. We're not necessarily using like materials imported that may not be available in 5 years. These are being developed. We choose the materials that either have been around for a while or are continuing to get stronger and stronger and being used more and more. We're trying not to be all so innovative with the product choices that it won't be around next year and then we don't have warranty on these things. So that's why, and we know we study the material really well to then, it sort of answers your question, I think.
Also, Chris's wife is a real stickler for design stuff and like the layout, so you shouldn't really need to, her idea is
Ever
you don't
change
ever feel like, ew, this place sucks. You know, it's like, it should be kind of a timeless.
That's right.
That's what we're next.
Can I answer anything else? Was that enough?
I've only had one beers, that's good enough.
They're right there. Beers are in the cooler right here.
I'm curious about the insurance question. Have you tried to get
So with this house didn't have any cavity insulation. We did 4 inches on the walls of stone wool and 7 inches on the roof. When she was going for her insurance, the owner, excuse me, they actually reduced her premium by 50% because it was so well built and so protected from fire, damage, insects. We looked at all of that, and it's the first time I've heard an insurance agent really paying attention to beyond code stuff. And so we had to explain that to them, but she got a 50% reduction. Yeah.
I have a house that does some nice things, and my appraiser did not give me any extra credit on it, and the insurance company did. So I think it's insurance company dependent.
All right. Chris has some great questions, and I've already lost my panel, so.
Yeah, just finish it up, Chris.
This isn't about me, damn it. Anyway, so this is Carl's house. I'm just gonna run, you guys can see that they're generic enough call outs that you understand the assembly. Same thing, insulated slab. He used zip R on the exterior, where the science is backwards, but that's another discussion. And then, like, why would you wear your hat this way?
Because you look
That's cool, man.
It's Matt Risinger.
I don't know who that is. And then what was your cavity?
What was that, R22?
That R22.
Which, you used R3, R6?
R3.
And then, you had something here, yes?
Yeah, just bats.
Just bats, yeah.
The red line is air.
The red line is the thermal boundary. It's kind of all your control layers. So this is a detail Carl and I both love, is doing your sheathing on top of your ceiling joists and then just filling it up with insulation on top, because it's totally uninterrupted, right? It's just a continuous insulation layer.
If you have nothing in the attic.
Correct. Yeah, you can't. No Christmas trees go up there.
Can I just jump in and say, Amelia and I actually like that. We recommended it to DOE that they make some cutaways of that, because
Yeah.
Great idea.
So.
All right, this is Carl's house. This is the Atlanta Craftsman. Yeah, you're not going to see that. So I told you there'd be data. Let's see, highlights of this. I mean, you saw it's super airtight. Look, our insulation is basically the R50, R50, R30 on the Craftsman, R20 plus R3 on this is total. And then R9 at the slab, R6 at the slab edge. Double pane windows, didn't go extreme, didn't have to. This is a split heat pump. He's got electric, 50 gallon. I guess these are the two things that I was mentioning. We still met all this. Our EUI is lower than his EUI for modeled anyway. And they also have a sauna heater and a cold plunge with a chiller runs.
Why don't you use SHGC?
Because most people are familiar with that. 54% is actually how much sun is allowed to pass through.
So 0.54.
Yeah, 0.5. It's not 0.5, it's solar gain. This is the number so passive house makes you build a window in Luffy. Like you cannot use NFRC. You have the frame, the psi value where the glass meets the frame, the glass itself, and then where the frame meets the wall. Like they want you to plug all that in for every single window. And if you have muttons, they want you to separate it out.
So what's the equivalent of NFRC?
It's about 30, 20, yeah, it's about 30.
Where did you find a window that's a 0.14 for a double pane?
Poland.
For what is that?
It's a European window, UPVC. Yeah.
That's insane.
Yeah.
Yeah, that is really it's like an R7.
So wait, go back. So your total capacity on the HVAC says 42.
So Mitsubishi, or the mini split system, the technology of the mini splits, the Mitsubishi, or any of the mini split VRF technology. Anyway, it looks like you're oversizing, but when I actually I use a software where I take the equipment, put it in, I virtually build the system at the location, and I know exactly how much my maximum capacity is going to be on the worst day, worst case scenario. I'm not using hyperheat, so I had to, but my heating loads, as you can see, our heating loads are smaller than my cooling loads, which is what most people think about in the South. Most home loads that we do, you all know at Energy Vanguard, most of the loads on normal built houses, they're either the same or sometimes the heating is bigger, right? When you go tighter, I found this on all high performance homes, the tighter and the more insulated you get, the cooling load actually starts to go above the heating. And so this is sized for cooling, but it has the heating capacity. So to get the sensible and everything that I need, these systems, so I plug it into the software and it tells me exactly, you know, what's gonna happen at lower temperatures, and what size my line set needs to be and how long it, you know. And that tells me like real world or modeled conditions. So it looks like, you know, my loads are pretty small compared to the size of the systems. The loads are 15, I think. Where'd it go? Up here. So that's the whole house, 3,800 square feet and 27,000 census. And then 20,000 heating. So anyway, I can leave this up going and bring us the numbers, but this is, I mean, a lot of this is just
Can I? Yeah. Makeup air?
what?
Makeup air for the kitchen?
Yeah. Yeah, I mean, it's actually, yeah, we've used a 14 by 8 duct that runs directly into, I don't have the drawing for it, but with me. But it runs into its custom hood. And so we're dumping the air into the custom hood, we're lining it with polywool. And we're letting the exhaust fan is right at the exterior wall. And then we have a 2-inch, 2 or 3 inch space with a grill, or with a little grill on it, all around the perimeter of the hood liner. And so the makeup air is dumping into the range hood while the fan is pulling it. So the air is coming in just like a commercial range hood.
And it's
like the NS Builders one.
Yeah.
Yeah.
Which that one doesn't work, but this one.
This one, because we've sized the duct thanks to your research and our own. See, mentors. But we've sized it well beyond the size of the exhaust fan, which is 10 inch. So it's 14 by 8, and so it's much bigger, and so we won't have that pressure. We won't have any issues with pressure.
And I'm so sorry, if you put a heater on that to do like an active system, will that make you fail passive house?
No, probably not. We have room. I don't know if you noticed the numbers, but we have room. Our targets are here. We have a lot of buffer space.
Are you using an ERV for mechanical ventilation?
Yes, but nothing fancy. I mean, it's a Panasonic ERV.
And that's pulling from the bathrooms as well?
Yes.
So you don't have any exhaust ventilation? And are you using a condensing dryer or a regular vented dryer?
They're regular vented dryers. So we're providing makeup air for the dryers. Yeah. Yeah. That's right.
One, don't ever put a heater on a passive makeup air. Two, on your detail where you have on your roof assembly, you mentioned the fabric that's beneath the rafters.
Yeah.
So that's not a one-way barrier, and there's no issues with that?
Nope. No, we don't. We ran the hydrothermics and we evaluated whether we needed a smart vapor retarder or anything, but because it's semi-conditioned, we stay dry and we stay cooler, and so the moisture doesn't present.
Well, now that all of our super nerds have geeked out for a while, I'm gonna ask some mere mortal questions here so the rest of us can understand. So guys, come on back up.
Yeah, really.
Yeah. Thank you all for coming.
Great,
No, I'm just kidding. So that was awesome. Let's get into some kind of more practical, like not more practical, but kind of easier to understand for the rest of us. Yeah. Well, you'll get a few too. So let's start with Allison. Allison, how does a passive house compare to other high-performance building standards like net zero or Earthcraft?
It's pretty far beyond, because, well, net zero could be passive house. It's all about whether you're balancing the energy you're using with energy that you are generating on site. So, but for passive house compared to Energy Star, for example, the passive house performance specs are much higher. You have to achieve much higher energy performance, and that's you end up with a better house.
Great. Carl, I know your house is linked to what they call a pretty good house, and Chris talked about it for a second. So what did you do kind of differently? I know we talked about it a little bit, and how is it different from full-on passive?
Well, I didn't meet passive house standards in terms of the insulation level, the ventilation system, things of that sort. But from a standpoint of energy use, it's pretty much performed at passive house levels. I mean, I think Katrin once posted all these EUIs of the passive houses, and my house does as well or better than all of them. Mm-hmm. So, it's just, I just think,
I think pessimism maybe a little bit of an overkill in our particular climate. I think it's one of the issues. That's kind of my opinion.
Yeah.
There are very good things about it, but the design for the insulation is a bit much.
I've done a prescriptive and a performance path method, and the performance path, which is basically you're modeling it, you're customizing the whole thing, that ends up being more reasonable. Like we're overkill on this one. If you look at it, we don't need all that to meet passive house, but the prescriptive path is overkill. Yeah. Like it does not make sense. Some of these, like if you have an 8-foot overhang or 8-foot window, you need a 6.7 foot overhang. Period. You can't if it's facing south.
Right.
Let me follow up on one thing, because so far the whole discussion has been focused on single-family detached houses.
Good point.
Passive house makes the most sense for multifamily, and that's where most of the passive house action is happening. Multifamily, especially in states that have good incentives for them. In New York, Massachusetts, they are doing a lot of passive house multifamily, and it's very cost effective because the incentives and the tax credits built into that make it a no-brainer, basically.
Correct.
Yeah, no, I think that's a very good point. It makes some sense. You get some economy of scale. The insulating the shell of a building that's got 100 units in it is much more cost effective on a per unit basis than insulating the shell of a single family house.
Right.
Same applies to geothermal systems. Geothermal makes more sense on a larger scale than individual.
Well, Andrew from Ecomec is not here to argue, so you're good.
Wish he were.
Technical question. Well, we've got Passive House Institute and Passive House Institute US. So what's the difference and who's better?
Depends on who you ask.
Yeah.
The difference is US.
Yeah.
I mean, it's for the US. It's now climate zone specific. It was. There are some people who still use PHI or the PHPP software, or the spreadsheet, and will certify a PHI, but it doesn't make sense because it's not climate specific. Yeah. So it can make sense in some climates that are similar to Germany, or other.
Let me give a little perspective on that. I was a board member for FIAS for 9 years and rolled off, and was an emeritus member for a couple of years. I just rolled off of that. So PHI is the German organization. It was created in Sweden and Germany by two guys there. And it came to the U.S. with Kat Klingenberg in the late 90s. She did the first certified passive house in Illinois and built the organization. I don't know if you know Kat. She is a force of nature. She is a power to be reckoned with. And she rubs some people the wrong way. So in 2011, there was this huge split based on personality differences. And so now there's two organizations, which is very confusing to a lot of people. But Kat has a very clear vision. She's a visionary. She's truly a visionary. And she saw that, yes, this idea of having one number or one set of numbers. There's a company in New York that sell great products, 475. If you've ever seen them advertised or seen their stuff, the 475 is one of the two main numbers out of the original program from PHI. 4.75 BTUs per square foot per year, I think, or something like that. And that number does not work in every climate. This program came out of Europe, which has a pretty mild climate. They don't have to deal with humidity issues. They came here, one of the early passive houses in like 2008 or something, built in Lafayette, Louisiana. They had a little bit of humidity there. It did not work. It was a big failure. And it led to some splits and how they did things. And when 2011, when the split happened, it was actually a really good thing because Kat took FIAS and created climate-specific standards. PHI is still, they're coming along, they're following our lead a little bit, but they're still stuck pretty much in the old ways. PHI does have a lot of traction in some areas. New York City, there's a lot of PHI. Massachusetts has a lot of PHI.
They also have a remodeling program with several incentives are tied to.
Yeah. So, but FIAS, in my opinion, and I'm a little bit biased. I even got my FIAS shirt on today. The FIAS is the better organization. They have better building science and
they speak English.
And have great.
They speak English.
Yeah.
So, Chris, as an architect, if a homeowner's interested in high performance, give me some pros to, you know, having a passive house, and how does it affect their daily life? Or does it?
Well, I think that, yeah, we start off by explaining that a passive building is really the goal. The certification itself doesn't change their way of life, right? It's the passive, it's the building principles that are involved, unless you value certifications and third-party verification of those sort of things, which are good. But as a builder, as a designer, you should require these third-party verifications anyway, whether it's a part of a program or not. I think I mentioned a few of them in here. The comfort level, the durability, because durability is a huge issue for them. They will call you out if they think you have an assembly that's not going to perform not just the hygrothermics. They'll actually call it out and say, hey, we don't think that's going to hold up very well. So I think durability, comfort, and air quality, it's all measured, and they just don't budge, and they want to make sure that they have they have those metrics. Energy, obviously, it's going to save you on your long-term costs, and I think it all depends on the homeowner's values, and what about it's going to help them. But I mean, people want this sort of thing. It's just about how to achieve it, and I think it adds to the value of their home and their life.
Yeah. Carl, are there any downsides to passive house?
I don't think technically there are any downsides. I think trying to deal with all the requirements, trying to manage the process is a nightmare. The spreadsheets, make me crazy, and I think they make most builders crazy in the process. I mean, I think there are some good things about it. I think you may not need the tightness of the envelope they're looking for, the fact that they are pushing a very tight envelope, they're pushing avoiding issues of condensation. It's not something you tend to run into in our climate a whole lot. The condensation issue tends to happen in climate zones 4 and 5 and further up. So I think it's less of an issue here, but it's good that we address it. One of the concerns I have is the requirements for ventilation are extensive, including supply air for every room. And my concern is that the cost to do that, I mean, there's a significant cost to build that into a single family house.
Yeah.
It's a great idea, but how many people can afford it?
And I think we're getting to a point now. We're evaluating that very thing, because I don't want to add cost. I don't want to just for the sake of meeting that. But at the same time, what we've come up with is a way to use a standard ERV and get the room to those systems in an efficient, cost-effective way. It's different than doing some ways to do ERVs, but it's doing the same thing, and it didn't add. I've done both, and I've seen it both. They cost the same. It just depends on how.
And the other frustrating thing is that there are precious few qualified mechanical contractors in the world. Trying to get competent installation is a challenge with standard equipment. When you're moving up towards more complicated systems, as you experience that.
Near impossible.
And by the way, the ones I've worked with in the past, they call me a pain in the ass and won't work with me anymore. Because
you asked. Well, it's
no, this is not a suggestion. This drawing that I did for you is not a suggestion.
Well, that's in our experience inspecting and testing houses. 99% of what we do is enforce competence, and it's really freaking hard.
Yep.
True.
And so the idea of making things way more complicated for people who can barely be competent with the lower level things is a real challenge.
Sure. Allison, how high performance do you have to go with your material selections? Do you have to use European triple pane? Do you have to use twice insulation values from code? What are we looking at?
So, great question, and I am not somebody who knows the details like Chris does, because I've never certified a passive house. I've been on the board. I know the general things about it, but I do know that in this climate, in climate zone 3 where we are, you can do double pane windows. You don't have to do triple pane windows here. Have you done any with triple pane windows?
I did, yeah. One of them in Georgia, one of them, and the other one, and then another one in Tennessee.
But it can work with double pane windows here, and early on when they first started going, they started changing the standard. I remember seeing some information from FIAS about how even in climate zone 3, it's possible. I don't know if it's ever been achieved, but it's potentially possible to do it with R13 walls.
Yeah.
So,
And the triple pane would be necessary on like a Marvin or an Anderson window, because you pointed out, the frames are awesome on those European, and that's where all that U value comes. You don't need the glass for that, because the frame is where so many linear feet of frame.
and we are getting manufacturers in North America who can do the European style windows. I did I'm finishing up a basement remodel, and we have windows, the tilt and turn double pane windows from a company in Vancouver that makes really good windows. They're called Innotech Windows and Doors. Great product.
One point about materials I want to make is there are very few bad materials. Almost anything, everything, if it's installed right, designed right, and installed right, will perform.
That's a good point.
There's just with a few minor exceptions, there's really nothing that's not a good material.
Arsenic in small doses is good for you.
Right?
It says right on there.
I wonder, one of the things that I had to admit, I kind of rolled my eyes because I saw the very first iteration of Passive House when it came to the US, and it just, it made sense for Germany, but it was a struggle to see the value. And, but one of the things I think that we haven't really touched on that I do think Passive House offers is resiliency. In other words, if it's really cold out in the winter and the power goes out, I think Carl's house is going to stay warmer for a longer time than my house.
Well, actually, the best example is my air conditioning, when I had a coil fail, my air conditioning went out on the top floor of my house in the summertime, and I kept the house comfortable by running the bath fans.
Yeah.
By just drawing air upstairs for about two
What's-
weeks until we got it
What's the
fixed.
story about the Passive House in Maine, where in the middle of winter, they lost power and it went down like 2 degrees over 3 days or something?
Yeah,
Middle of
that's-
winter, Maine, yeah. Interesting.
And resiliency is a big deal. People are,
Yeah.
we're getting a lot of off-grid requests for projects, and I've done an off-grid project, and we did a whole crap load of insulation to get there, and it's got autonomy for, I think, a month with its solar power, and that's what they wanted, and they had the money for it. But you design those assemblies to not need anything for that period of time.
Chris, this is for you. Maybe we can pull in Zane and Andrew on this too. Talking about costs, what is the extra cost for a passive house, and is there a break even with energy savings or anything along tax credits, anything like that?
He's the extra cost right here.
Yeah.
You're the extra cost, and
no,
no, go ahead, Zane, please, I want to hear.
Yeah, so, all right, again, I'm Zane Goodwin with Goodwin's Luxury Homes. I was just until recently the Passive House Alliance, I guess, representative for the Southeast. Now Andrew is that. I recently moved to California about 2 years ago, so now I'm over the Pacific side. And having gone through a whole certified passive house, project with these guys, I have an interesting debate point. Okay, so he said something very interesting, which is like, I've heard you can do it with R13 walls. I'll give you an example, specifically in the Southeast, in Alabama, Auburn School of Architecture, they have a group called the Front Porch Initiative, or it's the Back Porch Initiative, one of two. And they have, I think, about 7 houses apart, same house, face the same direction, roughly same architecture, small, roughly about 1,000 square feet houses. One was built to net zero ready, so effectively code compliance, R13 walls, a 0.3 window, just very normal construction basically, but built much more airtight than code compliance. Basically, somewhere in that 0.6-ish range, similar to what you would do in passive house requirement. And then they have also a house that is, one of the South's first, passive house certified homes. Interestingly enough, they've been tracking them now for about 3 years. I touched base with them about 2 years ago, and then just recently, like a month ago, they're performing almost identical.
They're identical. Yeah.
So I've been arguing with Passive House actually on this matter. It's like, it's one thing to say, hey, I'm gonna throw R50 in a wall and R90 in a roof and design that, and then like I can proof myself backwards by testing and be like, look, I hit these numbers. But what that doesn't prove is like, hey, I do this model, it says I need R50 walls and R90 roof, and then I'm gonna actually go and do R20 walls, and then test that. And my theory is that we're actually gonna see very similar, and again, we only have one use case scenario so far, and I think we need to do that to kind of prove ourselves. So with Steve and their houses, they kind of looked back and forth, and they said, hey, we're gonna do staggered stud instead of zip R product. And they found that performs pretty similar. So there's still a bunch of question marks, and I say this from like the Passive House Alliance side. At least for me, I internally question a lot of this that says, hey, I have a model that says X, and I think for us in the South, I think it's really hard to understand. You have like a parabolic hockey stick of R value. So I can say, hey, I have R100, but the real world is in all of these products, when you look at a U factor reality, is like that R100 doesn't perform but maybe 2% better than the R20, literally. So in this argument against, I think there's a happy medium somewhere where like if you just drop off and say we're not going to chase the last 5 or 10%, then we can get to something that's much more easy and much more straightforward that most of your average builders can apply. That is going to be 1 billion% better than code compliance.
You're talking about
but
the pretty good
without
house.
getting really crazy.
That's right.
Great.
What house?
Pretty good.
And there's nothing wrong with chasing that last 10%, right? That's an amazing house, and it's going to be.
That's what the pretty good house came out of, was people who were like really frustrated with passive house. And a lot of good information. It's very cold climate focused, but it's very good information.
Because we have to come a long way to get to where the passive house started. Like they're so far beyond, to make that leap all of a sudden here in the States is just impossible. So we do have to find the middle, but at the same time, I'm really glad they're pushing pushing the limits and making us push our boundaries, push things to where we can do better and leave the standard where it is, make it really hard, and let's keep doing more. It's happening, people are doing it. And I think if we have that standard there, we're gonna find ways to achieve it. It's gonna become more affordable. And I'm glad it's there. I don't think the country's definitely not ready for it to be a requirement like it is over there.
And in fairness, we build with a different goal than they do over there, right? They are building for generations.
Well,
we move every 7 years. Or
That's exact numbers actually.
Yeah.
And their energy is way more expensive than ours.
Yeah.
Like, I mean, our place over there, I mean, it's like 4 times the cost for energy. And it's, of course, that's why they don't AC.
I don't feel bad for you, but you're south of France.
Well, feel bad for the single pane glass that is on the southwest side that burns us.
So it feels like to me that passive house is going to, at this point in the market, is pretty much a niche product. I mean, this is it's an expensive product, and you've got customers that want it. That's great. But I tend to see this as like the analogy to the automobile industry, that race cars pushed, the developing high-performance race cars pushed a lot of the technology and advancements that then got adopted where practical into more middle of the road typical cars. And so we're all learning, I think, as an industry, what can be adopted, and the pretty good house sounds like it's done a lot of that. And that's really the benefit.
I agree. And here's what I learned by looking at Carl's house. Carl's house, I believe, could be a passive house home. It doesn't take a lot of money to reach passive house. I'm not yes, I'm the one that's selling passive house tonight, but only because I'm pushing for passive building. Passive house is our guide right now. Like we don't all have the skills to do passive design and building. But I think we could actually get more of them done. I've seen the metro, I've done a lot of modeling in Woofy, and I can see that you don't have to do a whole lot. And Mike, air tightness goes a long way in that. Like when I get that down to 0.05 on most projects, and all of the other assemblies and material, everything, components are pretty standard, like most people are doing with even semi-high performance. you drop that air tightness to almost nothing, which costs almost nothing extra, then you're there. And literally the extra cost on this project is Carl.
Can I add on to that?
Well worth it though.
No, but that's a small number, because he's doing the rating and of course the fees that go to FIAS. Those are the extra costs, and that's it.
Well, and the passive house consultant, the model.
Well, yes, I build it into our design.
Right, but anybody else can have to pay for it.
No, absolutely. You're right, sorry. Okay, me too.
So why not go Energy Star instead of FIAS? Like, I feel like FIAS is not realistic, but you said for all, we look at volume builders, you know, Monty Hewitt or Brightwater, some that are mid-level volume builders, it's not realistic to do FIAS for all homes. And I don't think it ever will be in our lifetime in an American building. But what about Energy Star? I feel like the cost there would be realistic. So what's the value to achieve a FIAS certification? Like, why even strive for that when we can strive for something that will provide benefit like the Energy Star?
Like Carl made the comment about products. Any product is fine if it's installed properly, but Energy Star homes get certified, not by you, Howard, but by, no. I just mean that there are so many Energy Star homes that I've had to come into afterwards that the raters pass it without looking at anything. It is such it's so off. There's so much of it going on. It's like.
It's the competency that's
it's
not.
It's the competency, and if you, and FIAS, there's no wiggle room. You have to get all these metrics, you have to prove it down to the T, and you can't get away with stuff. Energy Star, yes, if everybody did exactly, then we wouldn't be looking at FIAS. I mean, not as soon, because it's.
Real quick, and then I want to do a couple last things.
So from a homeowner's perspective, I got 3 builders are coming to me. One says I can do this passive house, one says I can do this pretty good house, and the other, Bubba, I built a stick house barely to code.
Pick that guy.
What's the He's the cheapest. He's the cheapest, for sure. What's the difference in cost between those 3? Identical looking house.
I was a contractor for 25 years. There's no way to compare contractors' pricing.
But you can't do it. I would say probably from the Bubba guy up to the pretty good, 20 to 25,000 for a 3,000 square foot house.
Nobody has any idea. We don't know what his house is.
But hold on, like, so here's actually the real question. Okay, so like what you're actually asking is like, if all 3 of those guys were to build the exact actual house.
Yes.
Right.
The top tier guy would probably be every bit of $100+ per square foot more, just because he knows what he's offering. Does that make sense?
But
Like,
don't look at retail, look at cost.
And Zane, I want to say this too. They're probably going to end up pretty close if they're building the same thing. He might just know what he's quoting.
This one's not going to be air sealed for crap.
Yeah, Bubba's not even part of that conversation.
I talked to a production builder that in Metro Atlanta that builds to net zero, and they sell in that, I think, the 800 to $1 million range. And to do net zero costs them about 30,000 more a house. That doesn't sound like very much. They've got their systems down and they do it all the same way, so that's different than a one-off custom.
But what is it $30,000 more from? Like what's their baseline? So is it,
from not doing it.
Envelope and HVAC.
Yeah.
But,
including the V.
Yes.
Yeah. So let's do a couple of quick hitters and kind of get us moving towards the end here. I'm just going to say kind of a 2-3 word sentence, and I want you guys to tell me what you think about it. So, performance versus prescriptive. Performance.
Well, for passive house certainly, because the prescriptive house is ridiculous. And I think that in any program, the performance path tends to make more sense because you have flexibility. Prescriptive, you got to do it. You put notes in. If they require X amount of insulation, you have to put insulation in.
Okay. Model versus actual. How close do we get?
it depends.
It depends. It absolutely depends.
But
You never know. And actually, behavior. I mean, how you use the house. It's like you could design a beautiful and build a beautiful house, and if the people leave the doors open with the heating and air conditioning on, it's not going to perform well. And people do it.
I was going to laugh. insulation in here. Passive house versus passive solar, what's the key difference?
Passive solar is kind of an old theory.
Passive solar requires a lot of owner involvement. I mean, you have to open and close your windows or put them on automatic, or passive solar is just about capturing the heat and using it later.
It doesn't really work. It's not really a southern thing.
well, Passive solar, true passive solar from the 70s is mass and glass. You have lots of glass facing south, you have big 55-gallon drums of water inside to store the heat in the day, or masonry, or trombone. That doesn't make any sense. I mean, we learned by 1980, people knew that super insulation and air tightness beat mass and glass. That battle was over by 1980. Passive solar features still make some sense, but you have to be careful, because when you are beefing up the enclosure the way we're talking about with passive house, you have a great potential to overheat those buildings. And there are a lot of passive house buildings that overheat because they tried to do too much glazing.
Big windows in passive house, is it a deal breaker?
Nope.
No?
Doesn't have to be.
You model it right.
Yeah, it's all about exposure diversity and which windows are facing this way, and if you have shading, if you have the right windows, the right glass. The glass is just getting so much better as a standard now, both from heat loss and heat gain. So we have plenty of big windows in some of these projects, and it's just about the design.
It's not big windows that are a problem, it's huge window to floor area ratio that's a problem. You gotta watch the window to floor
and the
area
exposure, yeah.
Last thing I want to do here is an idea that Chris came up with. This is called, is it BS or is it BS? So, is it building science or is it not building science? All right. A well-built house needs to be 0.6 ACH 50 or less. Building science or BS?
Depends on the size of the house.
Yeah.
I think the BS is that it needs to be, but yeah, I think it does depend on your goals and what you're like.
I think a well-built house can be 2 ACH 50.
There you go.
Less than 3.
Last thing. That's, like I'll shut up about air sealing. About air sealing in the southeast, one other really good thing is our tiny house in Florida was and it's tiny, so when you say 0.2 ACH 50, that's really tight for something so tiny. But we had probably the only house in Florida with 0 bugs inside. And so here in Georgia, we of course have that too, but it's not just air, it's moisture, it's
Dirt,
bugs.
dust. Yeah. I had we renovated a house once, and their allergies went away after they were done. I mean, there's a lot of positive health effects from a house that is not leaking.
Yep. All right. All houses in Georgia should have a fully insulated slab. Building science or BS?
BS.
Yeah, depends if they don't have a slab. It's like they don't need this.
Just a quick point on
Fine, Carl.
They don't all have slabs.
Just a quick point on when you're looking at just the science of it. One of my mentors kind of said to me, "Why are you insulating the underside of the entire slab? What about the cooling benefit of that slab?" But when you look at that, when you have to weigh also the heating demand and the heating losses and all of that sort. When you're weighing all of it in the balance, that 2-inch actually saves energy and is in general more comfortable.
Can I follow up on that real quick? Mark Rosenbaum lives in Massachusetts, and he had a house that it was an existing home that he bought. He did a lot of work on it, great house, uninsulated slab in the basement, and he found that uninsulated slab, because of the connection with the ground, would prevent the water pipes in that house from ever freezing. If the power went off, the boiler went off, there was no heat in the house, it would not go below freezing. Those pipes would be perfectly safe because of that connection with the ground.
Yeah.
Even in a cold climate.
40 degrees. A new way to look at resilience.
Yeah. Having a vapor barrier in Georgia is not important.
Depends where.
Under your belt.
Under the slab, yes.
Under the slab, yes. You don't
Not,
want,
not a slab, vapor barrier in
you
your
don't
wall
want
assembly.
vapor, and actually not, they're vapor retarders, not vapor barriers, and you don't want them in any walls or roofs.
There was, what was the name of that, there was a method of construction where it was like zero perm assemblies and all the insulations to the outside, and Martin Holliday was talking about it quite a bit back in the day. But it can still work, you can have a zero perm, it is absolute, you have to get all the other science right. You have to make sure that you have enough insulation to prevent that condensation, to prevent the heat loss and all of the moisture getting there, so you can do it.
It's a riskier
But it's,
assembly.
talk about costly.
Yeah.
Yeah, the chance of it being done correct is essentially zero.
And and that renovation will destroy it and then destroy the rest of the house.
Every home in Georgia should have a dehumidifier.
Yes. Bullshit.
Got one.
Yeah.
Okay, every house except Chris's house.
All right, let's get .02 ACH 50 maybe.
You have one, just hope it doesn't run.
Yeah. Okay. Allison, did you?
What's the question?
I said every house in Georgia should have a dehumidifier?
Oh, no, absolutely not. I've got a 1961 ranch house, and I don't have a dehumidifier, and our humidity stays less than 60%, almost all summer.
Ventilation.
It goes above 60, but just into the low 60s brief periods.
Is that ventilation? You contributed to
That's-
ventilation?
Well, the house is a lot tighter than it used to be. We're down to 7 ACH 50 now, it started about 14 or 15, and Howard knows the house, he did some analysis of it. And, yeah, it stays pretty good. Probably will put a dehumidifier in at some point, but we'll see.
We got two more and we'll wrap it up. All new builds in Georgia will have to meet passive house standards by 2050.
Who's the president?
Can we even get the 3
Oh, yeah, that's the key.
I gave us 25 years. I mean, that's a pretty long time.
I think that the people motivated to doing something like that are all in this room, and that's it.
All right, last one, and this is for Carl and Allison. So Chris was telling me that using spray foam negates the need for air sealing. BS or BS?
Using spray foam negates the need for air sealing?
Yeah.
It tends to do the air sealing if, depends on the design. I mean, I'm of the opinion that in a new house, spray foam is an excuse for a bad design, in general. But it's, if you create a funky design that you can't air seal any other way, spray foam is the best way to do it.
So I think, well, these guys know. To me, foam is a 4-letter word, it's an F word, it's never used on our job sites, period. It doesn't matter what we're doing, but this came up from, I was an expert witness in the project, and the attorney pulled out her Hollywood questions, looked at me and said, "Mr. Laumer-Giddens, is it true that spray foam negates air sealing? And does it negate R value?"
She knew what she was talking about.
Yep, nailed
I
it.
said, and after several, repeat that, can you reword it? What, I don't, the only answer I could give was no. I didn't know, I was like, I could have fun with this, but I want to go home.
You're billed by the hour, you just could have kept talking to her.
So no foam, that means only flat beers?
Yes. Yeah, I'm a Guinness guy.
Awesome. Well, thank you guys. You have any questions you want to ask before we get wrapped up here?
Can you have a passive house with a pet door?
Yes. Yeah, sure. Absolutely.
It's got a triple alcove.
Your front door is way bigger.
You can have a pet door, there's no cats.
Well, thank you guys. This was awesome.